If one shape's an enlargement of another, then they're said to be mathematically similar. For example, these two triangles here are similar. What that means is that this angle will be the same as this angle here will be the same as this one, and this angle here will be the same as this one. This triangle is an enlargement of this one here. There's a formula for finding the scale factor of the enlargement, and it looks really complicated, but it's actually very straightforward to apply. To find the scale factor of enlargement of these two shapes here, I just need to find two corresponding sides with measurements on them. So I've got AC here and PR here, and they both have a measurement on them. To find the scale factor of the enlargement, I get this side here, and the length is 15, and I divide it by this side here, and the length here is 6. Now 15 divided by 6 is 2.5, so the scale factor of the enlargement is 2.5. That means if I want to go from the small shape to the big shape, I multiply by 2.5, and if I want to go from the big shape to the small shape, I divide by 2.5. Now that you have this to help you, you should be able to find the lengths of sides RQ and AB. Press pause and have a go. When you're ready, press play. So to find RQ, I can see that the corresponding side here is 10, so I multiply that by 2.5. 10 times 2.5 is 25, so the side RQ is 25 centimetres long. For AB, that's here, I can see the corresponding side is here, and that's 20. So I'm going to divide by 2.5. And 20 divided by 2.5 is 8. So AB is 8 centimetres long. Now I'm given two squares A and B. To start off with, I'm being asked to find the linear scale factor. Well, that's exactly what we've just done. We want to find the scale factor that links the sides or the lines. So we have this side here, that's 6, and we divide it by this side here, that's 2. And that tells us that the linear scale factor is 3. In the second part, I want to find the area scale factor. To do this, I need to find the area of square A. Now the area of square A will be 2 times 2, which is 4. And I need the area of square B. The area of square B will be 6 times 6, which is 36. So to find the area scale factor, I'm going to get this area here, 36, and divide it by this area here, 4. And I get that the area scale factor is 9. Here's a question for you to try. Press pause and have a go. When you're ready, press play. So for the linear scale factor, we have 12 divided by 3, which is 4. To find the height of triangle B, I'm going to use the height of triangle A and my linear scale factor. So we have 2 multiplied by 4, which is 8. So the height of triangle B is 8 centimetres. To find the area scale factor, I need the areas of both triangles. Remember, the area of a triangle is base times height divided by 2. So for A, I've got 3 times 2 divided by 2, which is 3. And for B, I've got 12 times 8 divided by 2, which is 48. So to find the area scale factor, I've got 48 divided by 3, which is 16. So in the questions that we've just done, when we had a linear scale factor of 3, the area scale factor was 9. And when we had a linear scale factor of 4, the area scale factor was 16. You've probably noticed that the area scale factor is always the square of the linear scale factor. You need to make sure that you know this fact for the questions that are coming up now. So I'm now going to use this fact to help me answer this question. I've got a small octopus transfer. It's got a height of 15 centimetres and a surface area of 250 centimetres squared. There's a mathematically similar large octopus transfer, and that's got a height of 75 centimetres. And I want to work out the area of the large transfer. So the height of the small one is 15, and the height of the large one is 75. So if I can find the link between these two numbers, I've got the linear scale factor. Now 75 divided by 15 is 5. So that's the linear scale factor. Now remember, I want to work out the area of the large transfer, so I'm going to need the area scale factor. And remember, the area scale factor is the linear scale factor squared. So that's going to be 5 squared, which is 25. So the area of the small octopus is 250, and to find the area of the large octopus, I'm going to multiply that by 25. And I get 6,250 centimetres squared. This is the area of the large transfer. Here's a question for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Here's another question for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. I hope you realise that this time they were giving you the surface area of the larger pyramid. So you needed to divide by the area scale factor to get the answer. Now I have cubes A and B. I want to find the linear scale factor. We know that that's 6 divided by 2, and 6 divided by 2 is 3. I also want to find the volume scale factor, so for that I need the volume of both cubes. The volume of A is 2 times 2 times 2, which is 8. The volume of B is 6 times 6 times 6, which is 216. So to find the volume scale factor, I've got 216 divided by 8. And 216 divided by 8 is 27. So we've already seen that when the linear scale factor was 3, the area scale factor was 9. And we've just seen that the volume scale factor was 27. Now we know that this was this number squared. Is there a link between this number and this one here? Well, yes, you should be able to spot that this is 3 cubed. So the volume scale factor is the linear scale factor cubed. So here's an exam-style question. I'm going to use this fact to help me answer it. For this one, I would be allowed a calculator. I've got the heights of the two different size dinosaurs here, 10 and 12, so I can find the linear scale factor from 10 to 12. Now 12 divided by 10 is 1.2, so the linear scale factor is 1.2. I'm asked to find the volume of B, so I'm going to need the volume scale factor. So remember, the volume scale factor is the linear scale factor cubed. I would use a calculator to get this answer, and that's 1.728. So now to find the volume of B, I'm going to get the volume of A, that's 600, and multiply it by the volume scale factor, which is 1.728. Again, I would use a calculator for this, and I'd get 1036.8 centimetres cubed. This is the volume of this solid. Here's one for you to try now. Again, you can use a calculator to help you with this. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer.